Today, let's look at the Lintcode problem number 630. Shortest night shortest pass 2. You're given a knight in a chessboard which is m by m size. It's like this, right? So 0 means it is empty, reachable, and 1 means it is a barrier you cannot go. And the knight is initial position is 0, 0, and he wants to reach to the point position, actually the last position from the top left corner to bottom right corner. The knight can only be from left to right. We need to find the shortest path to the destination, and we need to return the length of the route. Return -1 if the knight cannot be reached. So basically this problem is just very similar to this one, knight shortest path 1. The only difference is that in knight shortest path 1 there is no restrictions, so basically the knight on the board can go anywhere. So that's why one knight can go to 8 different directions. But for pass 2, we have some restrictions. We only allow the knight can, go from left to right. So that's why we can only go to 4 directions, which is these. All right. So how do we do this? Actually, as we mentioned in knight shortest path 1, we use the way of DP dynamic programming. Let's just try to review this a little bit. We use the DP, and we actually use the quite unique way, different ways to calculate the DP. Previously, we just used the for loops, and then we calculate all the data points, all the DP data points by using the state transfer equation. But in this case, since we're looking for the shortest path, so it's easier for us to loop through all the DP points layer by layer, so that we can easily figure out their state transfer equations, because you jump from one layer to the next layer. Their DP relationship is like this. This is a source. You jump from the source. Your path is +1. It could be the destination's DP. But here, just to remember, we have the condition here. It's only if the destination DP is smaller, so we can update. I mean, the destination, the index and y, this DP is greater, then we updated it to be a smaller one. So this is what we did in shortest path 1. In shortest path 2, we're gonna just continue using DP, but we will go back to our old-fashioned ways to say how we can resolve this using for loops. Because for loops kind of like universal. We can use for loops to resolve the DP calculation in most of the cases. So let's see how we use the for loops. Let's directly jump into this code. This is our entrance. And first we do the parameter checking, and then we get the dimensions of this chessboard, m by m rows and m columns, and we initialize a seam size of our chessboard DP. The initialization value we give maximum int. That means it's not reachable. And we started from source, so that's definitely DP 0, 0 is 0, because there's no path length. Then we started using DP for loops. So this is like standard ways of writing it. So this part is the core part. How do we do that? Because when we calculate the DP, we still need to find the state transfer equations, between the states. So how do we find it? This is, it's like a jump. It's like a path searching problem. So it's easier for us to find the relationships between the source points and the destination points. So for when we loop through the I and the j, for current I and the j, and we can see that we try to find its sources points. How many possible sources this knight can jump from? So here we wrote the function or method. It is called get sources according to current destination I and j, which is our current coordinates. So we can figure out the sources, all the sources points that the knight can jump from, and we loop through all the sources and we update. We actually apply the state transfer equation. I and j stands for the current coordinates, or the destination coordinates, and sources 0, sources 1 represent the source where we jump from, the coordinates x and y. So sources plus 1 could be the destination dpij, but because dpij, we give a definition is that we jump from the beginning point to the ij, the shortest path length. So here we have to apply a main function. All right, so that's all. So after we loop through every data points, we try to calculate all the sources, state with this dpij, and we update this dpij. So after all of this is done, so we try to say our answer, because we need to figure out n-1 and n-1, which is the bottom right corner, this data point. So what is this shortest path length? So first we're going to check our DP array to see if we have a value. If we got like a max int, that means this data point is not reachable, so we just return -1. If it is reachable, we just return the DP's value. Very straightforward. Then let's see this method, get sources. We were given a chessboard. We have the destination coordinates x and y. We have a DP array, then we need to return the sources, possible sources. So here we just first we get the dimension of the grid, n rows and m columns. We initialize the list to collect all the possible sources, and here we declare the directions. Like we mentioned, the knight can jump to 4 directions, from the source to the destination. And here, because we got the destination x and y, we want to get all the sources. So the destination is just the opposite. So this is 1, 2. So here is -1, -2. This is -1, 2. So here is 1, -2. So this is how we define the directions array. Now we just loop through all these directions. We get the new data points, which is our source data points, and we check if this source data point is within the boundary all the way here. And also we're going to check that is this source data points, its DP value equals to max.int or not. If it does not, we're going to just append the sources. I think you understand these steps, right? If it is equals max int, that means this data point actually is not reachable. So there is no way we can just add it. So we only just add those reachable data points as our sources. Okay, and after that, we just return our sources. Yeah, so that's the whole algorithm. Let's just run this. Come on. Oof. Yeah, sometimes it's just super slow. Okay, wait. Okay, cool. It is running, and most of all of the test cases passed. So that's great. So I also have some notes here, just to basically compare the shortest path 1 and 2, and analyze the different mindsets already covered in these video tutorials. So that's great. Thanks for watching, and I see you next time. And please subscribe if you like those videos. Okay, thanks. Bye.